All right, so we're picking up where we left off last class, 5.2. We did one example in right triangle trig. So we're just gonna pick up there, do another one like we did last class, and go from there. All right, so we want to find the value of all 6 trig functions of theta. All right, so we have this triangle right here. They give us side C is equal to 3, side A is equal to 1, and side B is not given. So that's the first thing we need to do is figure out side B. Oh, put that in the wrong spot. And we'll use Pythagorean Theorem. All right, a squared plus b squared equals c squared. Remember, a and b are interchangeable, they're legs. The hypotenuse c is the one that most definitely has to be established and be on one side of your formula by itself. So plugging in quarterly, that'll be 1 squared plus b squared equal to 3 squared. 1 squared is 1, 3 squared is 9. Solving for b still. Subtract 1 from both sides. B squared is equal to 8. Take the square root of both sides. Square and square root will cancel, leaving you with b equal to the square root of 8. Also, you want your most simplified answer possible. You cannot take the square root of 8 evenly, but you are expected to simplify that if possible, and we can. And what I mean by that, let me go another color. If I have square root of 81, we know that's 9. If I have the square root of 16, that's 4. But if I have the square root of 32, I can't take the square root of that evenly. But what I can do is break it up into factors that can be taken the square root of and factors that cannot. (32) is 16 times 2. I break it up in that way because I can take the square root of 16, leave the 2 under the radical. Square root of 16 is 4. And 4 square root of 2 would be the most simplified way of expressing that square root of 32. You can break that square root of 32 into 4 times 8. Take the square root of 4, but the 8 still could be broken down. So you want to look for the largest factor, and in this case it was 16, the largest factor that you can take the square root of. So in all of your answers that you can't take the square root of values evenly, like here, you are expected to do this if possible. So when I look at the square root of 8, I can break that up into the square root of 4 times 2. Square root of 4 is 2. And I leave the other 2 under the radical. All right, so before we go any further, any problems with B or anything I've said up to this point? All right, scroll up a little. So now we have A is 1, B is 2 square root of 2, C is 3. Let me redraw. I think here, I know this was 2 square root of 2, theta, 1 and 2. Nope. This was 3. Trying to go off memory, then I'll check myself. Yeah, 1, 2 square root of 2. All right, so that's what we're looking at. Theta was in the corner, bottom left corner. Opposite of theta is 1. 3 is going to be our hypotenuse. And this is adjacent to theta, which is 2 square root of 2. So the reason why that's important, because that's how we said that we're setting up our sine, cosine, and theta. Sine is opposite over hypotenuse. That's so. Remember SOHCAHTOA? So that's 1 over 3. Cosine, adjacent over hypotenuse. That's 2 square root of 2 over 3. TOA, that's tangent. Theta is opposite over adjacent. So that's 1 over 2 square root of 2. And we don't want to leave our radicals in our denominator. So you are expected to rationalize the denominator by multiplying top and bottom by the square root of 2. If you go through the process, you multiply top 1 times square root of 2 is just square root of 2. On bottom, you have 2 square root of 4 because you have square root of 2 times square root of 2. And I'm just walking you through the process. Some of you already know this, but and the square root of 2, square root of 4 is 2. So you have square root of 2 over 4. All right, before we do the other 3 problems, any problems? So once again, try to write that as a note. Kind of got a little sloppy with it, but you must rationalize your denominator. That's what it says right there. All right, so the other 3, remember, are just inverses of the original 3. So we're just going to flip the fractions. So we have cosecant theta would be 3 over 1, which is just 3. Yeah. Secant theta is going to be 3 over 2 square root of 2. Cotangent theta is going to be 2 square root of 2 over 1. And notice when it comes to cotangent and tangent, I flipped this one. Just did that before I rationalized the denominator so that I wouldn't have to re-rationalize the denominator again. It'll just take me back to what I have up there now. And so go ahead and finish off secant. Multiply top and bottom by the square root of 2. 3 square root of 2, 2 square root of 4. So those are your other two. I mean, other three, excuse me. All right, questions before we do another one, or go to the next piece. All right. All right, cool. All right, so special angles. Normally in a face-to-face class, I would give you a little quiz on the unit circle. It's kind of hard to do that now and it actually be a legit quiz, because really all it was just memorizing the unit circle. And you know, in a classroom setting, proctored and everything, just to challenge your memory. But I don't know if I can figure out a way to emphasize that, and I will. But if not, it's not that big a deal. But you should remember at least these special angles. Got sine, cosine, theta. Whoa. Let me get my stuff back, trying to figure out how to take my page back. All right, give me 1 second, guys. I'm losing some of my room here. All right, trying to figure out how to get my page. Oh, I need more than that. All right, there we go. All right, sine, cosine, tangent. Half square root of 3 over 2. It should be square root of 3 over 3. All right, so sine of 30 degrees is going to give you 1/2. Sine of 45 degrees is square root of 2 over 2. Sine of 60 degrees, square root of 3 over 2. Then cosine of those respectively are these values here. And then the tangent of those are these. Also, just giving you a heads up. Cosine theta is going to be associated with your x coordinate. You know, when we talk about ordered pairs. Sine theta is going to be associated with y. And we're going to get deeper into that. Forgot which section, but just giving you a heads up so you start thinking in that way. All right. Like I said, that's going to come back up later. But when you look at your unit circle, it's really set up this way. We're just using your Cartesian coordinate plane. You have your origin here. Everything over here is positive. Everything up here is positive. To the left, negative. Bottom is negative. So when I go, let me go blue. And let's say I'm 30 degrees. This coordinate right here would actually be square root of 3 over 2, comma 1/2. And so that goes back to what we're talking about up here in the chart. Square root of 3, this is my x, these are my y's. All right, and that's the unit circle that I was talking about. And so you'll have all different types of different variations of using the square root of 3 over 2 and the 1 over 2. And then 45 degrees would be square root of 2 over 2, square root of 2 over 2. And then, and that matches up with my x here, y here. And then theta being 60 would be, that should be 1 over 2. I'm just thinking put 1 over 3. I'm sorry, that should be a 1 over 2. It'd be 1 over 2 square root of 3 over 2. So how does that help us when I go here? This right here is 90 degrees. Zero that's 360. Just depends on if you made your full rotation or not. This is 180 degrees. This is 270. So if you were to look at your coordinates based on what you know from your ordered pairs Cartesian coordinate plane, I will go to the right 1, and then that's 0. So that means cosine of 0 degrees is 1. Sine of 0 degrees is 0. So when you look at the coordinates right here of 90 degrees, that would be 0 for x and up 1. So that means the cosine of 90 degrees is 1. Sine of 90 degrees is 0. So all those things apply. So the same thing is going over here. Let's say if this is 90 degrees, sorry guys, they were getting a little too loud. Threw me off. Anyway, so same thing applies over here. Looking at this 180 degrees, you know, I would go to the left 1, 0, 1. I mean left 1, then 0 for x. So the coordinates here, cosine 180 degrees is equal to -1, and then sine of 180 degrees is equal to 0. So just showing you how that unit circle works. It applies the same way your Cartesian coordinate plane would work, and they're just variations of the square root of 3 over 2, and 1 over 2 is your coordinates. Like if you were to add 45 to 90 degrees, that would be 135 degrees. So 135 degrees here. But to the left, to go in your second quadrant, is left. Let me write it like this. I know I'm throwing a lot at you. I probably will send you a picture of the unit circle. To get in your second quadrant, you go to the left, which is negative, and then go up, which is positive. So that means the coordinates would be negative square root of 2 over 2 and square root of 2 over 2. And that coincides with 90 degrees plus your 45 degrees. That's how you get to 135. So I'll send a copy of the unit circle to you guys so you can see what I mean. Like I said, I hadn't thought about doing it, or even, I probably won't do a quiz, but at least show you what I mean by, if you haven't seen it before, the different coordinates, and all of them are just variations of square root of 3 over 2 and 1 over 2. And you're just using your different signs according to the quadrant that you're in. You know, both of them will be positive in first quadrant. Third quadrant, you're talking about negative, negative. Then in the fourth quadrant, positive and negative coordinates. So I'm gonna shoot that to you guys, and then we can talk about it more after you looked over it. See if you have any questions on how it's set up. So we'll reserve more conversation for next class on that. It just hit me as we were going over it. So, all right. So next thing in this section is the reciprocal, and we've already talked about this, but I'm just putting it on paper. Got the reciprocal identities. So then you have your quotient identities, where tan is equal to sine over cosine. So if tan is equal to sine over cosine, that means cotangent is equal to cosine over sine. All right, so given that sine theta is 2 over 5, cosine theta is the square root of 21 over 5, find the remaining trig functions. Ooh. All right, so if sine theta is 2 over 5, that means cosecant is 5 over 2. If cosine theta is square root of 21 over 5, that means secant theta is 5 over the square root of 21. If we have a square root in our denominator, we need to rationalize. So we multiply top and bottom by the square root of 21. So that means when we finish this off, it'll be 5 square root of 21 over 21. So those are the first two. All right, so next one is tangent. That is sine over cosine. So 2/5 over square root of 21 over 5 is the same thing as this. You know, this divisional symbol and this are the same. One is written vertically versus the other one written horizontally. So don't forget, whenever you're dividing by a fraction, you're multiplying by the reciprocal. So 5s will cancel. 2 square root of 21. So now we rationalize the denominator again. Multiply top and bottom by the square root of 21. So that'll be 2 square root of 21 over 21. Cotangent is flipping our tangent or reciprocating our tangent. Remember, like we did before, I can flip the fraction before I rationalized it, and that will give me my reciprocal. So that'll just be square root of square root of 21 over 2. If I were to flip this one, then that will give me 21 over 2 square root of 21. Then I have to rationalize it again, and it'll take me back to that. So that's why if we just flip this one, we'll be good to go. All right. Everybody good? Everybody okay? All right. So let's look at next thing.
Can I ask you one honest question about that last topic?
Yes, sir.
And it'll realistically help me sleep better at night. When is anybody actually going to use that?
Oh man, you know when you go to Walmart and just when you're buying groceries, I'm just joking.
To figure out which aisle to go down? Yeah.
Right, exactly. To be honest, it really depends on your major or your area of expertise.
Okay.
Yeah, if you're doing social work, I can't see it coming up. You know what I mean? Like, of course, engineering, physicists, any of your science majors, you could run into mathematical happenings, period. You know what I mean? Especially algebraic. Depending on how deep you are in the sciences, trig may come up. Um, Computer programming can pull in some stuff. Like a lot of holograms that are made with using calculus, and a lot of calculus uses trig and then using algebra. It just depends on your area of expertise. I can't promise you that you're going to see this in everyday life.
I can promise you I'm never going to see it. So this is the college getting money out of me. Yeah, okay.
Yeah, I plead the fifth on the college getting money out of you, man. Hope that makes you rest better, man.
It will. I'll sleep better tonight.
Pythagorean identities. All right. What happened to my thing? All right, I messed that up. All right, so we got one. Life ahead is dealing with this. Check the chat if you want another answer for your concern. So here are our Pythagorean identities. Sine squared plus cosine squared is equal to 1. 1 plus tan squared is equal to secant squared. 1 plus cotangent squared is equal to cosecant squared. The one that most definitely, well, hopefully, I will hope that you will remember them all, because if you can commit them to memory, you can commit them to usage. But most definitely, the one that will continue to pop up is this cosine squared plus sine squared equal to 1. If you don't remember all three, that one most definitely will continue to pop up as you continue to progress throughout this course, and in calculus and other things. But that sine squared plus cosine squared, they like to beat that like a drum. So let's look at using this as an example, using one of these at least. This is again anyway. Anyway, I'll just leave it like that. All right. So given that sine theta is 3/5 and theta is an acute angle, find theta or find cosine theta using a trig identity. All right. So we have to be careful here because they give us something key that I touched on a little. And I'm surprised because they hadn't really emphasized it in the book yet, unless I just missed it, but it doesn't matter. Touched on it a little bit, and it matters. So it says that theta is an acute angle. Now remember, we're dealing with our angles in standard form. If our angles are in standard form, that means that this is our start, our initial side, and our terminal side, and it's positive. It is going this way. So if it's an acute angle, that means our angle is going to be in our first quadrant. So angles in first quadrant. And if our angle is in the first quadrant, that means both. Oh, let me write. So if your angle is in the first quadrant, that means both sides of your coordinates are positive. So we're talking about, and if both sides of my coordinates are positive, remember we said that this one is cosine and this one is sine. So now if they said theta was acute, that means cosine would have had to have been negative. This cosine that we're about to find would have had to be negative. And then you may ask yourself, well, how come can you just put options there? Well, you'll see what happens when we go to solve. But I just wanted to point that out before we just continue on, that the fact that it is an acute angle does matter. All right, so let's look at the only relationship that we just explored between the Pythagorean identities that involves sine and cosine, of course, is the sine squared plus cosine squared equal to 1. And sine squared, well, sine is equal to 3/5. And I didn't emphasize this, but sine squared theta and sine theta squared are the same thing. It's just notation. All right, so 3/5 squared, 9/25. Subtract 9/25 from both sides. So don't forget your fraction work. We have 1 minus 29 over 25. I can't just subtract those. I need to turn this 1 into 25 over 25. And then I can subtract. Remember, if you're going to add or subtract fractions, you need a common denominator. So 25 minus 9 is 16 over 25. All right, make sure we are okay. Now to get rid of this square, I need to take the square root. Square and square root cancel. Now, so don't forget your square root property. So all of your rules still hold true from algebra. You know, nothing changes just because we have moved from algebra to trig. So whenever you do the square root property, you take the square root of both sides. Plus or minus has to be involved. I don't need that. Square root of 16 is 4. And so that's 4/5. Square root of 16 is 4. Square root of 25 is 5. But I have this plus or minus that I have to give an account for. So how do I know which one will work? And that goes back to the fact that our angle was acute and cosine is supposed to be positive. So because theta is acute, theta is in quadrant 1. That means cosine theta is 4/5. All right. Questions on that before we and we got one more thing to mention. All right, so cofunction identities. All right, so cofunction identities. Notice the ones that are paired up this time: sine and cosine, tan and cotangent, secant and cosecant. Just says sine of theta is equal to cosine 90 degrees minus theta. And then same thing, you just flip it for sine and cosine. Then tangent is equal to cotangent 90 degrees minus theta. Flip those for tangent and cotangent, and then do the same thing as far as the relationship between secant and cosecant. And then if your theta is in radians, then instead of 90 degrees, you would be using pi over 2. All right, so so we have we want to find a cofunction with the same value as the given expressions or the given trig functions. We have sine of 72 degrees. So the cofunction relationship for sine is cosine 90 degrees minus that 72. That's just cosine of 18 degrees. Then the next one, secant. We have cosecant of power 3. So we'll do secant pi over 2 minus pi over 3. So you're going to have to find a common denominator, which is 6. Multiply top and bottom by 3 by 2. All right. All right. So finish it off with secant, and that's pi over 6. All right. Questions on those? Trying to see if they have word problems in this section. Well, we can do one. I'm not so sure, but we can do one. So I say, will there be word problems on the test? I have to check what I did before. It'd probably be about maybe two of them at the very most three. I see the thumbs down, but I know at least two of them, so it wouldn't be enough to cause you to get a horrible grade, or yeah, it wouldn't be enough to cause, like, if you got everything else correct, you still should be able to squeak an A out. So yeah, so I know I at least have two up there. All right, sorry for the depressing news. So angle of elevation is an angle formed by a horizontal line and the line of sight to an object that is above the horizontal line. Really, every problem is made up of words. I agree. And then angle of depression, pretty much the same thing, except that it's below the line. So it's the same definition, except this is an angle formed by a horizontal line and the line of sight to an object that is below the horizontal line. That is your angle of depression. So that angle direction will go down. All right, so let's do at least one word problem using these before we close out today. Let me see how it works. Oh. All right, give you guys a chance to write this down before I scroll up. They actually give you a diagram. I remember back in my day, they didn't give us diagrams. We had to figure it out. So, you know, at least they're looking out for you guys a little bit. So as citing the top of a building, a surveyor measured the angle of elevation to be 22 degrees. The transit is 5 feet above the ground and 300 feet from the building. Find the building's height. Like I said, I'll give you a few seconds to write that down, then I'll scroll up so I can draw and then calculate. All right. So let's see if I can draw this without this thing looking too crazy. I guess I should have drew this as the ground. It's supposed to be the ground, it's a little lumpy. Um, So I said, what time of day is it? Yeah, they didn't get that deep into it. And yes, the example is on page 596 if you have the book in your possession. So I did my best. Got my little guy here looking into the transit. The transit is 5 feet off of the ground, so that's what this represents over here. It's 300 feet from the man, or from the transit to the building. And 22 degrees is the height, not the height of elevation, the angle of elevation. So we are going to use, oh, let me say this too. From the top of the building to this 5-foot mark is what is created by our triangle. That does not include the 5 feet that's missing by the use of the transit. That's from the height of the building. So we're gonna have to include that when we look at it at the end. So we'll talk about that more so at the end, at 5 feet. But let's look at what A would represent, or what number A would be. We have our angle, which is 22 degrees, and we want to include in our calculation this 300 feet and A. So remember, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Our 90-degree angle is over here. So that means this is our hypotenuse. So we don't want to use the cosine or sine because they use the hypotenuse, and that's not really a part of our calculation in this diagram. So we will use tangent of theta, which once again is opposite over adjacent. So that means we're going to do tangent of 22 degrees. Also, make sure when you're doing calculation in your calculator or with your calculator that you're either in degrees or radians accordingly. Right now we're dealing with degrees. If your calculator is set for radians, you will get the wrong answer. So make sure you're careful with that. Opposite of 22 degrees is our A. Adjacent to 22 degrees is the 300. All right. So now that we have the setup, we want to solve for A. So we'll multiply both sides by 300. Cancels. A is equal to 300 tan 22 degrees. And that is approximately 121. Any questions on that part? And once again, that's something you would throw in your calculator. So now just keep in mind, we're not finished because there were 5 feet that we had to give an account for. That was a part of the building's height that was not a part, or it was not recorded by the transit created with line of sight and all the good stuff like that. So we just have to, in order to calculate the height, do A plus 5, which is 120. 1 plus the 5, that's 126 feet. So that should be the height of the building. All right. So we got 5 minutes left. We're pretty much almost out of time. So try this stuff out. See if you get stuck. Feel free to email me if you have questions. If it can't wait until class, or you can just wait till class and ask them, and we'll go over it then. On the test, will it tell us how many decimal places? Yes, it should tell you how many decimal places. If it does not, then and you were correct, and they marked it wrong because they wanted 1.1 instead of 1.2, 1.12 or something like that. Just tell me, I can adjust the score accordingly. But it should tell you how many decimal places to use in your answer.
So are the tests going to be in my math lab or?
Yes.
Okay.
Yes, test will be in my math lab. For your test, make sure that whatever submission you give me for your test, you send me your notes, not notes, but work to show that you actually put in the work to do it. That will be the record that I have that you guys actually did it and everything like that. So make sure you show the work. Um, we will, any test that I give will be in my math lab. It's just that the first few of them won't be necessarily proctored. I think the only one we'll probably proctor is the final exam. So make sure that you're taking advantage of that. Make sure that you're doing your best to learn the material and not necessarily cheat on, the test that you don't have to be proctored on, so that when you are proctored, you can successfully complete the test without any issues. Um, any other questions before we close out?
As as
Huh?
far as calculators, is there a certain one that you recommend that we have, or just any old calculator will do for this course?
Yeah, pretty much. You don't necessarily have to have a graphing calculator or anything like that, or nothing expensive. You just want it to be scientific so that you can use cosine, tangent, and sine with no issues. Being able to see pi and different things like that. So you want it to be a scientific calculator. You don't want it to be a basic four function calculator, but you do not have to spend a whole lot of money. I would suggest that whatever calculator you use, like I said, make sure it's scientific, but also make sure that you can put the whole display in there. So in other words, what I mean by that is that you can put parentheses, 1 plus 2 plus cosine, and close the parentheses out and see it all in your display before you hit enter. That would be the ones that will be most beneficial to you. Ones that aren't like that, you'll have to perform order of operations, do everything in steps, in which that gives, you're human, that gives more room for error to occur, when all you could do is just type it all in and then hit enter. So I would suggest that type of calculator. And those aren't expensive anymore. So I'd say aren't crazy expensive. I don't know what everybody's level of expense is, but or $20, something like that. Get you a nice, decent calculator. All right.
Thank you.
Not a problem, not a problem. I see one more thing. When you say proctor exam, is that going to be on campus? No, no, nope, 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 not on campus. It will be through the Zoom. I would open up the window so that I can see everyone. Everybody would actually have to come in, and you'll have a heads up notice on what that day would be, what that date would be. And so that means everybody can be video ready. If you don't if you don't want me to see you looking any kind of way. I know ladies want to make sure their appearance is straight and all that good stuff like that. So you'll have your date out there. You got to make sure that I can see you. So it's cool that I don't see you during the lecture. That's fine. But on the proctored day, I do need to see everyone's video. I need to check you in by ID and stuff like that. And like I said, I don't know how long this quarantine thing is going to last, but let's say if we do it again next semester, you may run across a teacher who may make you have two different video links on you and a lockdown browser and stuff like that. So you might as well get ready for that type of idea. And they may do every single test being proctored versus me just doing the final exam being proctored. So there are levels to this proctoring thing and the seriousness of it. So just keep that in mind as well. For the exam, then will a specific calculator be needed? Cell phone will work because I've downloaded a free scientific calculator for my cell phone, so that'll work as well. Right. What to say? Okay, yeah, yep. So like I said, cell phone is fine. Once again, though, what I do in my class, I probably should cut it off record. But my class is like Vegas. What goes in my class stays in my class. I can't, give you a green light for anybody else's class. So if you go to PreCalc 2 and you don't necessarily get me, and they have a stricter demand on how tests are done or the proctoring of the tests and stuff, that's what I'm trying to make sure I prepare you for. Don't look at what I'm doing and think that that's how everyone is doing it. Yeah, like I said, there's levels to it, and some people are more strict than others and everything like that. So just throwing it out there. Anything else before we close? Everybody good? Everybody straight? All right. So have a good one. Oh, did somebody say something?
What's the name of the book?
The book is Algebra and Trigonometry, 6th edition by Blitzer. So Algebra and Trigonometry, 6th edition by Blitzer.